Okay, welcome everyone. This is the second step to the second CML exercise from the soils topic. If you haven't completed step 1, which we published in a previous video, please make sure that you do, because you will need it to get going to step 2, obviously. So in this step, we're going to be looking at using the Van Genuchten function, which is this equation that you can see right here. And what we're going to be trying to do with it is to obtain values similar to what we did in step number 1 for that soil, which is soil number 1 over there. So as you know from before, all we need to do is fill in the question marks with either values or formulas. But before we actually get started on that, I think it would be best if we actually plot these values from step number 1 in a graph, because it'll make things a bit easier to see when it comes to using the solver function, exactly what the solver function is doing for you. So to begin with, just go to Insert, make it a line graph, pull the line graph down below, select Data, Add, and then the series name, we'll call it the pedotransfer function or pedotransfer. The values will be these values here. Okay. Then go to the x-axis label range, and that is just going to be our matrix potentials over there. Okay. Right, so now we've got a little graph here, which is actually those values, which we obtained in step number 1. And the reason we're doing this will become obvious in just a little while when we actually start doing step number 2. So to get going on step number 2, the first question mark is M. And but before we actually tackle M, probably I would suggest you change the values here to what you have in your sheet to what you can see over here. The reason for that will become obvious again in a little while, but trust me, just change the values, it'll make things a little bit easier. So M, if you look at the equation up here, is just equal to 1 minus 1 divided by n, right? And it's always going to be that, so that's the end of that function. We never have to change that again. The next question mark we have to play with is this one over here, and this is actually going to be the Van Genuchten function there that has to be entered here. What can be tricky about this is the bracketing and also the use of an absolute value, which is these two straight lines that you can see next to the matrix potential over there. Okay, you can see that these values line up, right, with those values there, and because of that, we can obviously just target these matrix potentials here for those values in there. Okay. Anyway, I'll just get going with it, and hopefully you can follow on. So the first thing we need to do is obviously put an equals in, and theta r is the first value we need, and this is theta r right here. Right? Now we don't know that this is the exact value of theta r. These are pretty much, you could call them surrogate values, and we just need them initially to formulate the equation in Excel, or to get the equation a value in Excel. And again, you'll see why that is when it comes to using this solver function in a minute. Now theta r needs to be fixed, because when we drag the function down, it will copy it to the cells below. We don't want that target cell to change at all. So, and the next bit is, okay, so it's theta r plus, and then we need to open a bracket. We need theta s. Theta s is our saturated water content, which we know is this value over here, right? So that's theta s. And again, this one also needs to be fixed, because it's not going to change when we copy the cell down. So theta s minus theta r again, and we fix that one again. Now we can close that bracket. Now we've got another bracket that needs to be opened, but there needs to be a multiplication sign between them. So in Excel, multiply is a little star like that. Open a new bracket. Now, when I'm going to be doing multiple brackets, I like to actually close the bracket straight away, so I have a bracket pair. So I know that bracket and that bracket I've already put in. Okay, then click inside and do 1 plus. Now we need to open another bracket, right, which is this bracket over here. And again, because I'm opening multiple brackets within each other, I like to open and close the bracket immediately, and then actually move my cursor in between the brackets I've just opened up. Right, so I know I've got that pair sorted. Alpha, we need a value for alpha, which is this value here, and that needs to be fixed as well. Right, so put a $sign there and a $sign there. And alpha is going to be multiplied by the matrix potential, but the absolute value of the matrix potential. And what that means is we ignore the negative sign. Okay, so in Excel there's an absolute function which is just AVS, right? And then again we open and close the brackets, because whatever is in those brackets is what we take the absolute value of, and in this case it's just the matrix potential. Right, so for this one it's going to be 0 over there, and these are the matrix potentials. So as we copy this formula down, it will keep targeting the different matrix potentials, so we don't need to fix that value at all. Okay, now here's the tricky part. So outside the first bracket, outside this bracket, right, needs to be nothing, right? But it's outside that bracket there. So in between the last two brackets is where this n has to be, right? And to do something to the power of n, we put this little hat, which is above the 6 on your keyboard, in case you don't know, and it's the value n, and n will need to be fixed. So put some $signs in there, and then the final one is then to the power of, again, m. But notice it's negative m, and that's something people always forget, which tends to cause big problems later on. Okay, and then we fix that one as well, right? And that's it. If you want to double check that you've got all your brackets set up correctly, what you can do is just move your cursor till you cover a bracket and make sure that it has a matching bracket. Right, so you can see I'm moving along there, and you just click over it and you can see Excel will highlight the partner bracket for you. Right, so yep, we've got all our brackets sorted out, all our brackets are partnered up. Okay, that's it. Then you just hit enter, and as a check it should give you the same value as this one over here. Right, if it doesn't, you've done something completely wrong. If we now take that and copy it down, first thing we need to do is check that we're still targeting the correct cells. Right, so we want to target the lower matrix potential. We're still on our saturated water content for theta S. Theta R is still where it should be, so is alpha, n, and m. Okay, so everything seems to be working fine for that setup. We can just now copy the formula down to the rest of the cells, and we've got values for everything. Now, what we actually want to try and do is get these values to match these values over here as close as possible. And as you can see at the moment, they're slightly different. Okay, so what we do is we have a look at the sum of squared differences between them. If you don't know exactly what the sum of squared differences are, I suggest you go and look it up, because it's going to take me a little bit too long to explain exactly what it is. But all it is we're going to be entering the sum of squared differences here. So I think in the procedure, which is over here, it tells you exactly what function that you need to use. So it's the sum x m y2, argument 1 and argument 2. Right? And argument 1 will be this range of numbers here, and argument 2 will be that range of numbers there. But anyhow, you'll see me do it now in a second. Is equal to, right? And then if we hit S, U, M, right, it's starting to narrow down on the list that we want, and it's actually this bottom one here that we're after, right? So S, U, M, X, M, Y, 2, right? These other two, which look similar, a few extra letters in there, are not taking the sum of squared differences. They're actually adding things, whereas we're subtracting things. So that's the main difference between these. So we want this one here. right? So just double click that, puts it in, and it opens the bracket for us. So the first array is this range of values here, right? Then a comma. Second array, which is asking for over here, are these values here. So what this function essentially is doing is looking at the differences between the cells and then taking or adding them all together, right? So those are the differences between the two cells, and they're added all of them are added together. The reason they're squared and then the square root of it is taken is so that we ignore any plus or minus, right? So in other words, you can see this one is smaller than that one, but there may be another value here which is greater or something like that. So the sign doesn't matter whether it's plus or minus. All we're trying to do is get it as close to those values as possible. So the reason it says minimize this using the solver is because the smaller the difference between the two ranges of numbers, the closer they approach each other. Now we're assuming that this range is correct, and we need to change the parameters of the Van Genuchten function here, right? Because these values depend on these values. But we don't know that these values are correct. We're just assuming, or we've just put some surrogates in there in the meantime. And the way you can see this is actually if you plot these values as well. You can see how far away this function is in comparison to that one. So let's just do that quickly. If we go click on the graph, click design, select data, then click add. Right, so now we've got a new series. We've got the Van Genuchten, and our series values are these over here. Right, so you can see the red line is the Van Genuchten function, and it starts off okay over there, but it's nowhere near the blue line here, which is actually where we want it to be. Okay, don't need to worry about the x-axis again. It's not necessary. So just click OK. Okay, so we could do this by trial and error, just keep changing these values until we get a line that matches, right? But that could be tedious because the amount of times you'd have to change one, then you'd have to change another one because it changes the line a different way, that sort of thing. So if you want to, you can play around with these numbers manually by just changing them, as long as you stick to these constraints over here. Right? So if we were to just change this one to 1.6, so to speak, you can see our line shifted here slightly. Right? Let's change it to 1.3, and watch the bottom corner here of the graph when you hit enter. Right? You can see it just moves slightly. Right? Let's change this one to, or let's change n to 1.4. Right? Whoa, that was a nice big jump. Right? So now the line's getting closer. Right? So you can see this is the manual way of what they call optimizing, or trying to figure out what these values need to be to get as close a match with this function to what is predicted with this function over here. So the pedo transfer function is the one we believe to be correct. And what we're trying to find are these Van Genuchten parameters here, right, which will make these values match those as closely as possible. Right? And why we want to do that, I'll explain in step number 3, because I guess you can see that here we go from 0 to -20 straight away. There's actually quite a bit of information that is required when you first, or when soils drain, and you can use it. You can obtain that information using a Van Genuchten function, but you can't really with this pedo transfer function because the resolution just isn't good enough. We don't have the information in between these values, which may actually be quite important when we're examining soil. So, instead of having to do this manually, what we can do is use Excel solver. Right? So if you click in there and go to data, I don't have the solver enabled. I'll just do that quickly. Right? Just should have done it in number 1 already, but if you haven't, you can just follow this procedure now. Okay, so first go to File, then Options, then Add-ins, right? Thing called Solver Add-in there. Click it. Make sure this says Excel Add-ins and say Go. Then tick the Solver Add-in there and click OK. If you're still under the Data tab, you should now have an Analysis section with solver underneath it. Make sure you've still got that cell ticked over there, and then click the solver button. Okay, so what's come up is this is our target cell, L33. So this is the cell we want to have a smaller value as possible, because a smaller value as possible here means we've got as close a match of these numbers to those numbers, right? That's essentially what it means. So the target cell has to be minimized, right? We don't want a specific value, we don't want a maximum, we just want it minimized, so as small as we can possibly get it. And we need to change cells. Which cells are we changing? We're changing this range of cells over here. Right, so it's going from K20 to K22. Yep, K20 to K22. And it's only the 3, not the M as well, because the M is dependent on the N. So make 100% sure you don't actually include the M in the cells that you're going to be changing, because if you do, you'll never converge on very good numbers. Okay. Now these are the constraints, right? Cell K21, which is this one here, must be greater than 0. Just get rid of that. Must be greater than 0. Right? K20 must also be greater than 0. K22 must be greater than or equal to 1. Right? Which is what it says here. But there's an extra constraint here which also says that K20 must be less than 0.2. Right? And that's missing from here. We need to add that. So to add a new constraint, all you have to do is click Add. Click the cell reference that you want, which is this one here, right? That'll pop up there with K20. Less than equal to, which is what we want, and the constraint is 0.2, right? And just click OK. And you can see now we've got an extra constraint that's appeared in here. So cell K20 has to be less than or equal to 0.2. Cell K20 must also be greater than or equal to 0, which matches the constraint set out here. K21 greater than 0, correct. K22 greater than 1, correct. Okay. Now, there are some options with regards to the solver that you can play around with, but to begin with, let's not bother with that at all. Let's just run the solver as it is, because this is all we need. Notice the number, it's something to the -3 at the moment. And have a look at our graph. This first line matches quite well, but the red line isn't doing as good a job as we'd like. Right? So let's see if we can get a better match by changing these numbers, and that's exactly what the solver function is going to do. It's going to change these numbers here. Right? You can take note of what they are right now, but the solver is going to actually alter them to try and get as best a match as possible to that blue line. Okay, so if we just hit solve, right? So now you can see it's asking us if we want to keep the solver solution. If we have a look, we can see how nicely the match is, or how well the lines match. So our red line now matches our blue line very well. As another check, you can see whether this number's been minimized anymore, and yes it has. It's a lot smaller than what it was before, 2 orders of magnitude smaller. And that's great, right? I'd be pretty happy with that as a match. So let's just click OK. You can see these values have been altered. They are still within the constraints, or right, that's between 0 and 0.2. That number is greater than 0, and this number is greater than 1. Right, so that all looks great. Now, yeah, well, that's actually it for step 2. I'm going to end this video and do a second one or another video for step number 3.